Thank you, Darren. I'm Corie, and today I am going to talk to you about, I'm going to talk to you about our topics of our discussion. Daphne here is going to start off introducing us to what an engineered well pad is. Then we are going to talk about integrating environmental conditions into our location feasibility and site selection process. Daphne is going to talk about pad, access road, and erosion and sediment control measures, the design portion of that. I'm going to talk about the importance of reclamation and as-built data, and then we are going to finish off with some pros and cons of engineered well pads. Spoiler alert, there are more pros than cons. I'm also going to tell you right off the bat what our take-home message is. Upfront, thoughtful planning equals minimizing and mitigating your risk. So please keep that in mind as we go through our presentation, and if you go home with that today, we did our job. So with that, Daphne, could you please let us know what an engineered well pad is?
Thank you, Corie, and good afternoon, everyone. So the easiest way to explain to you what an engineered well pad is by showing you examples of pads that were not engineered. So on the screen here, you'll see several photos of issues that you've probably likely experienced in the field or dealt with on your own sites. The first photo here on the left is some stormwater ponding around a tank battery on an existing pad and erosion starting around that tank battery. The next photo is of some severe ponding on the surface of a well pad. This probably looks like a photo of a lake, but I assure you this is actually a photo of a well pad surface, and you can see the berm, perimeter berm on the pad in the background, and then actually there is a lake in the back, further in the background. That berm is to keep any contaminants on the pad, but it's also keeping the stormwater on the pad, which obviously we don't want super saturating the surface of that pad. The next photo is of a large gully that is causing erosion off of a pad and leading sediment into the adjacent roadside ditch that you can see in the background of this photo. And then finally, this is a pad surface that's severely rutted, likely due to some stormwater ponding, as we discussed on the previous photos. And it could also be a result of maybe inadequate compaction during construction, or possibly the wrong kind of surfacing, or maybe not enough surfacing placed on the pad surface. So we can't just show pads that were not engineered, so we'll go ahead and show you some photos that we took with our drone of some pads that we actually did a civil engineer design for. So in this case, the operator needed to place these pads in an area of very rough terrain. So they came to us and they thought it would be worthwhile to spend a little more time up front with some design and planning so that they could identify any issues that they're going to have in the long run. So you'll notice thoughtful placement of BMPs, such as silt fence, stormwater outlets, riprap channels. It's kind of hard to tell in here, but we placed the topsoil pile at the top of the cut slope to kind of divert that stormwater around the site. We paid close attention to approach location and dealt with the county on that. And then we also work with the facilities and drilling teams with the operators so that we can provide an optimal pad layout so we don't have any wasted space. So Corie, where do we start?
The best place to start is at the beginning. So our client would like a well pad and access road to go somewhere in that general area, so that red polygon. We'll call it our study area. And now the client could have just decided they know exactly where they want the pad, right? There is always that perfect location. And so then they would send out survey to acquire topo, and then they would build the design. And so they would then send environmental and cultural out to essentially clear the area. But what happens if there was Dakota skipper habitat that was directly impacted by that well pad? More money would need to be spent to send out survey, environmental, and cultural back to the field to collect more data. And then the design team essentially would have to start back from the beginning. So in this situation, how about we send environmental and cultural out first? They can include any protocols that any federal agencies might need. They can collect the data, see what you're dealing with, and then we will take that data, give it to the design team, and they can design around those environmental constraints. Essentially, when you look at this, right, there's a lot of unknowns until you get boots on the ground. All that we're doing is mitigating that up front. Let's see what the environmental and cultural teams found. So you can see there's a wetland in the bottom of the drainage. They delineated some Dakota skipper habitat. And the archaeologists found some cultural sites. Now, all of this data is ready to be packaged and given to the design team so that they can incorporate that into their location feasibility and site selection protocol.
Location feasibility and site selection, also known as the scoping phase. This is where the design team does a desktop analysis and a field review of the potential well site. So during the desktop analysis, we look at the watershed for that area via topographic maps. We also look at historical aerial imagery for the area so that we can look for evidence of maybe some scars that would lead us to believe that there's existing utilities or other infrastructure in the area. In areas where there's really rough terrain, sometimes we will utilize publicly available LiDAR data, and we'll bring that into a CAD drawing, and we'll do a rough grading of the area so that we can identify any potential issues up front. We also look to see what county or township or state agencies that we will have to be dealing with and what standards we'll have to follow in order to design any roadways or approaches so that we can make sure that we're going to be able to meet their needs. And then finally, we take the environmental report that Corie's team gives to us with all those constraints so that we can consider those whenever we're doing our design. So then we do the field review. We send out a designer to take a look at the actual site in person so that we can identify anything that maybe wasn't noticeable in our desktop analysis. So some of the things that we look for in the field review include site distance. So like I said before, we want to make sure that we're meeting those minimum standards that are set forth by the local township or county for our approach that we are proposing to access our site. With that, we also want to look at the spacing of any of the existing approaches, especially if we're planning to place a new approach so that we don't have any issues there. We also look at any nearby new infrastructure that maybe wasn't noticeable in the historical imagery. And that can also be identified by utility markers that we didn't notice in that imagery as well, or above ground utilities that wasn't noticeable. And then finally, we just take a look at the terrain. Sometimes things jump out at you when you're actually there in person that maybe you didn't notice in the desktop analysis. So then, once we narrow down the area, which is clear of all the constraints and the issues that we discovered during the scoping phase, we move on to our design phase. So when we do pad and road design, the major thing that we focus on is our stormwater analysis. We take a look at that watershed that's coming onto that project area, and ideally, we want to place our well pad at the top of the watershed. If we have it at the top of the watershed, then the only water that you have to deal with coming onto the pad is the water that's falling out of the sky. However, situations are not always ideal, especially in the oil field. So oftentimes we are having other water coming onto the pad and we can't place it at the top of the watershed. So in those situations, we take that stormwater data and we analyze it and we design a combination of stormwater ditches and diversion berms to mitigate that stormwater that's trying to come onto the pad and get it ideally to go flow around the pad, or if it does have to come on the pad, we make sure we handle it appropriately. Next, we work with the facility and drilling teams with the operator so that we can provide an optimal pad layout for their activities and equipment that has no wasted space. And like I mentioned before, for the access design, we work with the local county and township, sometimes the NDDOT, to make sure that we are meeting their standards that they have set forth and making sure that that approval process happens seamlessly and smoothly. And then we also use their standards to do improvements to existing roadways that might need to be utilized as part of the project. And then finally, we can work as a liaison with a geotechnical firm to coordinate a geotechnical analysis for the site, because we want to look at those important factors such as your specific fill factor, your topsoil depth, and your surfacing alternatives. So let's apply this back to the example that Corie brought up. On the screen there, I know it's really hard to see, blue represents the fill area on the pad. So on the bottom right is that a big fill slope on the pad, and then the top or the left side is a topsoil pile. So here we were able to work with the geotech report They gave us the depth of that topsoil so that we could accurately depict the size of that topsoil pile on that plan. That helped us out in this situation because this particular pad was constrained on all 4 sides. We had a county road on one side, and then the other 3 sides we had the environmental constraints that Corie's team found. So we didn't have a whole lot of space to put a topsoil pile, but we were able to determine in our design phase that the amount of topsoil on site, we could likely squeeze it in there like we did. Secondly, we were able to use that topsoil to place it left on the screen view that you see is north, which is where that watershed's coming onto the pad. We were able to place that topsoil pad on the top of that cut slope and then divert the stormwater around the pad so that you have less stormwater that you have to handle when it comes on down around the pad.
So let's see how the design team did with their pad design and how that comes into play with the environmental constraints that we had given to them. It's always a good practice, right, for us to look at the preliminary design, environmental. So this way we can make sure that nothing was missed. We can ensure that all applicable buffers are being met. And if there are any concerns, these things can be brought up right up front. Here is Daphne's design. So for the most part, they did a great job, right? They avoided all of the shapefiles that we had submitted to them. However, I would go back to Daphne and her team and express some concern with that southwest fill slope and its proximity to the wetland. Again, that appears to be a very steep grade, and I would just want to ensure that the erosion and sediment control devices that they design adequately prevent any soil from leaving that site and entering into that wetland.
Yep, so in regards to what Corie just said, as part of the design process, it's good practice to always include an erosion and sediment control or reclamation plan as part of the design package. Basically, the plan just shows thoughtful placement of your BMPs, such as your straw wattles, your fiber rolls, your erosion control blanket, riprap channels and plunge pools, stormwater outlets, silt fence, etc. This does 3 things. So first of all, it provides a guide for your contractors so that they can provide a precise bid for their stormwater things that they're going to lay out in the site. And there's no question about whether they put the things that you had planned for. Secondly, it provides a guide for your owner or a plan for your owner so that they know that they're getting what they expect. And then thirdly, it provides a guide for your SWIP inspectors so that when they are providing feedback to the contractor or owner so that when they have to do some fixes on the sediment controls, everybody's on the same page. So let's apply this back to the example. This is the same pad that we've been talking about. That fill slope is in the southwest corner, north is up on this view. So we took into what Corie said, we took that into consideration and we placed erosion control blanket all on that entire fill slope. Lots of straw wattles, as you can see, fiber rolls down both sides of the fill slope where the fill slope meets the existing ground so that we can capture that concentrated flow and slow it down. We have our stormwater outlet at the top of the pad that's letting the water from the ditches around the pad out. Ideally, we would not allow that water to flow down to a big drainage or a wetland. However, water flows downhill, and in this particular instance, that was the only way that we could get it out of the pad. So we just implemented extra precautions, such as we have a riprap plunge pool at the top where the outlet's at, and then we have a riprap channel all the way down the slope to another riprap plunge pool at the bottom to just really slow that water down and allow it to sheet flow out of that plunge pool. And then finally, we did 2 layers of silt fence at the bottom at the end of the fill slope so that we have that extra protection, and hopefully we will not have any sediment leaving site towards the wetland.
As far as reclamation goes, we have one ultimate goal, right? To establish grass. To take it a step further, we would like that grass to establish quickly to reduce any surface erosion. And we would like deep fibrous roots to hold that soil in place, especially on those steep slopes. To achieve this, we need to have a site-specific seed mixture that was designed with accounting for your location, your soil texture, your percent grade, and any other special conditions such as salinity. Look, you can't just throw any seed on anywhere and expect it to grow, right? Certain plants love certain soils. So let's match them up and ensure that what you plant actually establishes. Because let's face it, temporary BMPs should be just that, temporary. The quicker you can get grass to establish, the quicker you reduce your probability of having major erosional features that would make you need to have somebody come back out, regrade, reseed, and restabilize that soil. As important as reclamation is, collecting your as-built data is just as important. Again, this is making sure that what you planned is what was built. This holds your contractor accountable. The other part of that is your engineered well pad is only as good as what was actually built. So to take it a step further, you can incorporate SWIP inspections into your project, right? So your SWIP inspector is not only going to let you know that your BMPs were installed, but if they were installed correctly. An example of this would be that top middle picture. You can see there's a gully forming underneath of that straw wattle. So water is actually cutting underneath of that straw wattle because it actually wasn't even designed, or it wasn't installed correctly. It wasn't trenched in, so water just cuts underneath of it. SWIP inspections can also help so that you can catch problems faster before they become bigger problems. All three of those pictures showing erosion concerns need to be addressed. And if they're not addressed, they become bigger problems. So now if you actually have your as-built data in place and you have stormwater inspectors, this time when you need to come back out there to have somebody regrade, reseed, and restabilize that soil, because you had those things in place, and because you can prove maybe that that contractor didn't install those correctly, this isn't on your dollar this time. This might be on the contractor's.
So as Corie mentioned at the beginning of this presentation, the benefits of civil engineered well pads ultimately outweigh the cons. So what are those benefits? Well, here they are. Reduced cost and time saved during construction. Your contractors can bid apples to apples so that they can provide competitive bids against each other. They construct projects according to precise standards and details, so there's no unknowns during construction, and more likely you will not have any change orders, hopefully. Stormwater mitigation is what we've been talking about through this whole presentation, reduces long-term operating costs and maintenance. Minimize risk of dealing with your regulatory agencies that might issue fines or investigations due to non-compliance. Your neighbors and the adjacent landowners are happy and content because you don't have sediment and erosion leaving your site, affecting their crops and their lands. Your civil facility and drilling teams are working together to maximize your pad efficiency and effectiveness. And then finally, improve safety. This is a big one in our industry. The risk of pad and road failure are minimized, and exposure to unsafe roadway conditions for your people as well as the public is drastically improved. So what's the catch? Well, operators will likely invest a little more money up front for an engineered pad versus your traditional well pad plat. But the bottom line is those upfront costs are just a drop in the bucket compared to the time and money you'll save over time. So we want to leave you here today to think about a few questions. I want you to ask yourself, how much money does it cost for you to have your civil contractor remobilize and come to your site to clean up a muddy, rutted up pad and possibly place some additional surfacing? Or how much money do you lose when you have to shut in a well because your people aren't able to access the pad because of a roadway failure or maybe a flooded culvert that couldn't handle the rain event? Or how much money do you have to pay in fines because you had erosion on your pad that had sediment leave the site unknown and enter into and impact an adjacent wetland? And then we'd like to leave you with one more question. Which one
would you choose?